All right, so here we have cars traveling downhill at 30 miles per hour on a wet pavement. When the braking distance B in feet for this car is given by the formula below, where m is less than 0 is the slope of the hill. So B equals 30 divided by zero point 0.3 plus m. We need to find the braking distance for m is equal to a negative 0.25 and interpret results, and then find m if the braking distance is 500 feet. All right, so for A, what we have to, oops, A, what we have to do is we have to go ahead and plug in the negative 0.25 for M. So B, well, quit doing that, please. B is equal to 30 divided by zero point 0.3 minus 0.25. So that's going to be 30 divided by 0.05. Move the decimal 2, move the decimal 2. So that's going to be what? B is equal to 600 feet. So 600 feet braking distance with the slope equal to negative 0.25. So that's part A. Now part B, now we have to solve for M when B is 500. So 500 equals 30 over zero point 0.3 plus M. So I'm going to do cross product again. So when we do that, we're going to have the 500 times the zero point 0.3, which will give us 150. And then that's going to be plus, what's that, 500m? And then that's equal to 30. So now we subtract 150. And so 500m is equal to a minus 120 divided by 500. So m equals, and now if we take 120 divided by 500, that's going to be a negative 0.24. So that's all it asks for. Find m for that. It doesn't say interpret that one, but you know, this one be when the braking distance is 500 feet, the slope is a negative 0.25. So that's going to be what that one is. So that's the 24, not 25. What am I wrote wrong number there. 2, 4. Okay, I looked at 2, 5 up here, not on the calculator, which was 2, 4. So that's going to be our slope when we break at 500 feet, and at 600 feet, slope is a negative 0.25. All right, what's the next question? All right, so it says on a certain river, a paddle boat travels 10 miles upstream, which is against the current, in the same amount of time it travels 30 miles downstream with the current. If the current of the river is 5 miles per hour, determine the speed of the boat in still water. All right, so let's kind of draw a picture here. And so let's say that's our river, and our current's going this way, and the rate is 5 miles per hour. So going this way, our rate is going to be equal what? Well, let's call x equal rate of the boat. So that's going to be what? Well, it's going to be x minus 5. Now, if we're going this way with the current, our rate is going to be x plus 5 because we're going to have an extra speed with that. Now, it says it can only go 10 miles this way, whereas it can go 30 miles this way. So that's going to be our distance. Okay. Now, with this problem, distance is equal to rate times time. Now, this is going to be the same time it goes each direction. So what we're going to do is we're going to solve for t. So t is equal to distance divided by rate. And so we're going to set this basically time equal to this time. And so we're just going to have to find those pieces and plug them in. So the one going against or upstream is going to be what? Well, that's going to be 10 divided by its rate is x minus 5. And that's going to be equal to the distance the other way, which is 30 over the x plus 5. Now we need to say what is the rate of the boat. So we have to solve this for x. So that's going to be 10x plus 50 equals 30x minus 150. So if we add 150, subtract 10x, that cancels that, and that cancels that. And so what do we get? We get here 200 equals 20x divide by 20. So it looks like x equals 10. That's the speed of the boat, miles per, whoa, miles per hour. So that's the speed of boat. Okay. So that would be our solution here. Okay. So yeah, so that was what we have for our answer there. What about, okay, let's pause there and we'll come back for some more.